Every 39 seconds, there's a new cyber attack. That's 2,200 attacks a day. Here's the kicker. Some of those attacks powered by artificial intelligence. But AI isn't just used by hackers, it's also being weaponized by defenders. The problem is we don't fully understand the consequences of trusting AI to run the front lines of our cyber defense. And if we're wrong, lives, data, and national security are at risk. So, can we trust artificial intelligence to guard our networks, protect our identities, and fight the battles that we can't even see? Or are we inviting a smarter, faster, invisible enemy into the heart of our defenses? I'm Dr. Derek Smith, the Cyber Professor, with decades in the field, from military intelligence to DHS to private sector. Today, we're tackling one of the most pressing questions in our industry. Can you trust AI in cybersecurity? Is it a lifesaver or a silent liability? This isn't science fiction, it's happening right now. And if you're leading security for any organization, you can't afford to miss this. Because whether you're a CISO, a student, or just trying to keep your family safe online, this tech is already making decisions that affect your life. Let's unpack what it can do, where it fails, and what the future holds. Cybersecurity has changed. It isn't what it was even 5 years ago. Yesterday's attackers used brute force and simple phishing. Today, we're fighting AI-generated phishing campaigns, polymorphic malware, and real-time botnet coordination. Here are the key problems. Number one is volume. Security teams are drowning in alerts. The average SOC deals with over 11,000 security alerts per day. Speed. Attacks unfold in seconds. Detection in minutes. That's too late. Complexity. Multi-cloud, hybrid IT, remote IT, Internet of Things, too many endpoints, too little visibility. And 4, human burnout. Analysts are exhausted, response times are slipping, and staffing shortages are brutal. The threat landscape has exploded. 70% of attacks now come from advanced persistent threats, or APTs, using automation. Phishing emails generated by AI tools like WormGPT or FraudGPT are prevalent. Deepfakes are being used in real time to impersonate executives. And cloud misconfigurations are targeted by bots scanning 24/7. Security teams are drowning. As I stated, the average SOC sees over 11,000 alerts per day. Human analysts are burned out, they're overwhelmed, and they're under-resourced. The average dwell time for an attacker before discovery, still over 200 days in many industries. And attackers are automating, using GPT-style tools to craft phishing emails, using AI to bypass multi-factor authentication, using machine language to find exploitable misconfigurations faster than humans can patch them. Traditional defenses, firewalls, SIEMs, antivirus, are reactive. They only detect what they already know. AI was introduced to shift us to proactive security, but with that shift comes new risks. We've got a massive visibility gap, and attackers are using automation to exploit that gap faster than humans can respond. Enter AI, promised as the solution, but also a new kind of risk. Let's break down how AI is being used in cybersecurity today and what each approach actually means. I'm not just talking about buzzwords, I'm talking about tools and techniques used by real security teams. Let's start with anomaly detection, or machine language-based IDS/IPS. AI is excellent at finding the needle in the haystack. Machine learning models train on normal network activity and raise red flags when something deviates, like a user accessing terabytes of data they never touched before. They use tools like Darktrace, Vector AI, and ExtraHop. Machine learning models analyze your network and define a baseline of normal. If something deviates from that, like a contractor logging in from Asia at 3 a.m., or someone downloading gigabytes of files they've never touched before, it raises a flag. An example, again, is Darktrace, using self-learning AI to monitor patterns and detect threats without signatures. 2 is threat correlation and intelligence fusion. AI connects the dots faster than humans. Let's say an endpoint downloads an unusual DLL. Separately, a DNS query is made to a shady domain, and the same user just clicked a phishing link. AI tools now scan threat feeds, paste bin dumps, darknet forums, malware databases, and correlates that into one high-confidence alert, something a human might miss buried in noise. What took human threat intel teams hours, AI does in minutes. For example, Google Chronicle ingests petabytes of telemetry and builds a high-fidelity risk profile. Number 3 is automated triage and SOAR. AI doesn't just detect, it acts. AI helps prioritize alerts, kick off playbooks, and even take action like isolating an infected machine. That's the magic of SOAR, security orchestration, automation, and response. It can isolate a device, kill a process, revoke credentials, all before human analysts even check the alert queue. But if improperly tuned, it might quarantine a critical server by mistake. If AI is misconfigured or overzealous, it could shut down your production server thinking it's ransomware. Speed without context is dangerous. 4 is User and Entity Behavior and Analytics, UEBA. This is behavior profiling for cybersecurity. Imagine every user, device, or service has a behavioral fingerprint. AI compares what's happening right now to what's historically normal. AI learns how users behave, when they log in, what files they access, how often they travel. A sudden change, say logging in from China and downloading HR records, gets flagged. But here's the catch. AI is only as good as the data it's trained on. If it hasn't seen a threat before, or if the training data is biased or poisoned, it can fail hard. But again, it's not perfect. Let's be honest. Here's where AI stumbles. False positives. Too many alerts still create noise. Data bias. If the AI is trained on bad or limited data, it won't recognize new threats. Adversarial AI. Attackers can feed bad data to confuse AI models. And black box logic. Many AI systems don't explain why they made a decision, which is a problem for compliance and trust. Let's examine a few AI case studies, success and failures. In one incident in a financial services firm, Security Copilot spotted anomalous API calls linked to unauthorized data movement. Human analysts had missed it, but Copilot recognized that the user's behavior didn't match their baseline and isolated the account in seconds. A full-blown breach was averted. That's AI at its best, augmentation, speed, and accuracy. But then there's Capital One. A former AWS employee exploited a cloud misconfiguration, downloaded over 100 million customer records, and no AI raised a flag. Why? Because the access appeared normal in terms of credentials. This is the dark side of AI trust. It didn't understand the context, and that's the risk of putting AI in charge without oversight. So where is this going? Let's look ahead. Deception AI, tools that deploy fake data, fake systems, and fake identities to trap attackers. Zero trust orchestration, AI managing adaptive trust levels per session and behavior. Explainable AI, future systems will justify the decisions to build trust. And cyber risk AI governance. New frameworks are being built to regulate AI use and security, just like we did with encryption and privacy standards. But here's the truth. AI will never replace skilled humans. It's not about set it and forget it. It's about human-AI partnership. Just like in aviation, the autopilot helps, but the pilot is still accountable. Here are a few more risks. Model poisoning. Attackers can corrupt your AI's training data. Shadow AI. Rogue tools inside your enterprise can use unauthorized AI APIs. Legal gray zones. Liability for AI-made security decisions is still undefined. And over-reliance. Treating AI as a replacement, not an augmentation, will backfire. The real future isn't man versus machine. It's man with machine. AI is your co-pilot, not your commander. AI in cybersecurity is here to stay. It can detect faster, analyze deeper, and act quicker than any human ever could. But it also introduces new vulnerability and is only as good as the people who build, train, and oversee it. So ask yourself not can we trust AI, but can we trust how we're using AI? Now is your turn. Drop a comment. Do you trust AI to guard your systems, or is it just another risk waiting to be exploited? And if you want to know how AI is being used by cybercriminals, check out my next video, AI versus hackers. Who's winning the cyber arm race? I'm Dr. Derek Smith, your cybersecurity professor, and I want you to stay alert, stay skeptical, stay ahead of the threat, and as always, be a cyber hero. I'll see you in the next video.